All right. So today we're talking constant rate of change. Before we can talk constant rate of change, we have to talk regular rate of change. So what rate of change is it's the speed at which a variable changes over time, or at which variables change over time. So essentially, what this is saying is how much is each variable changing and how that's related to each other. So if I just call this the x value and I call the money earned the y value, then if I was looking at the rate of change, I would look at how much each variable is changing at each step. So from 1 to 3, we're going up 2, so positive 2. From 3 to 5, we're going up 2, so plus 2. 5 to 7, same deal, plus 2. So we're going up 2 every single time. Now, if we look at our y values, we're going to do the same thing. We're going to look at the difference in each one of these. So from 10 to 30, we're going up 20, so positive 20. 30 to 50, up 20, so plus 20. 50 to 70, up 20, so plus 20. All right, so we've looked at how much each variable is changing each time. And now for us to figure out our rate of change, we would actually look at our y value, or our change in y, over our change in x. And anytime you see this triangle, that's a way to say change. It's a Greek thing. It's they used the triangle symbol. It was delta, and that means change, essentially. So change in y over change in x. So now we're going to go ahead and calculate that for each of these. So for this first one, we would say change in y, which was 20, over change in x, which was 2. Now we're going to look at our second one, 20 over 2, and it's 20 over 2 again. Now, if we look at all three of these, they're the same. So this example would have a constant rate of change, because all a constant rate of change is it's how much it's changing each time, and that has to remain the same. So typically we would reduce these and say this rate of change is 10, 10, 10. So our constant rate of change would be $10 per hour. So hearing these rates should seem somewhat familiar. Dollars per hour, miles per hour, feet per second. Anything that kind of has that per in it is typically a rate. So constant rate of change, like we said, it's the same thing that we just talked about in this previous slide, except for it is going to be the same every time. So let's double check that. X was blue. So we can do the same thing. It's the same example, but I'm just going to fly through this one. So our changes in x were 2, 2, 2. Our changes in y were plus 20, plus 20, plus 20. And if we remember, it's our change in y over our change in x. So we would have 20 over 2, 20 over 2, and 20 over 2. And when you're writing a constant rate of change, it has to be in its most reduced form. So we can't leave it as 20 over 2. It has to be 10. All right, so that's constant rate of change. We're just calculating it that way using tables. So in this example here, they say the balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? So does it form a straight line? If so, find the constant rate of change. If not, explain your reasoning. So anytime we have a linear function, so it makes a straight line, there's going to be a constant rate of change because it's following that pattern forever and ever. And so what we're going to do is we're going to do our same test that we did before just to figure out if there's a constant rate of change. So my changes on my x side, plus 3, plus 3, plus 3. My changes on my y side, minus 30, minus 30, minus 30. So right away, I see that it's changing by the same interval every time. So I know there's going to be a constant rate of change. So my next step is I need to write that constant rate of change, which is going to be my y value, my change in y, which is negative 30, over my change in x, which is positive 3. And then I would simplify that. You could punch it in your calculator, or you could simplify it longhand. I know if I divide negative 30 by 3, I'm going to get negative 10. So my constant rate of change is going to be negative 10, or negative $10 per transaction if we put it in terms of this particular problem. So when we look at our y side here, it's going down $30, and it's going down $30 per every 3 transactions. So if we simplify that out, it's minus $10 per transaction. So the other piece of this problem was they wanted to know if it was linear. We can say, yeah, it's linear. We found the constant rate of change, so we don't need to explain our reasoning. Boom. Lovely. All right, so let's look at one more of these. It's the same deal, just slightly different. So we have our x's and we have our y's. So let's look at our changes in x first. So we go plus 1, plus 1, plus 1. So it's changing by 1 every time. And if we look at our y's, we change by plus 8, plus 8, plus 8. Okay, so once again, it's changing by the same interval every single time, once again. And so for me to write that, well, first we can say, yes, it's linear. Secondarily, we have change in y over change in x. So my change in y is plus 8 over my change in x, which is plus 1. So my rate of change would be 8, and I'm going to say $8 because that's my charge, or my y value. So $8 per my x, which is hours. So $8 per hour. Okay? Lovely. Moving on. So I want to look at this example here. This is kind of a different one. It's a little bit weird, but it's important to look at one of these because they're going to be slightly different than those two that we just did. So determine if there is a constant rate of change. If so, calculate it. So we're going to go through the same steps. We have our x's on this side. We have our y's over here. My change in x is plus 2, plus 2, and plus 7. Okay, so that's a little bit different. We have plus 8, plus 8, plus 24. Okay. Did I mess this up? Yep, because I can't add. Plus 28. So, now we have all of these kind of lined up. If we look at our first one and well, first of all, they don't change by the same thing every time. So we go +8, +8, +28, +2, +2, +7. So that should kick something in your head saying, okay, something's not quite right here. So right away, we can't say that it's a constant rate of change off the top, but if we simplify all of these, so we have 8/2 for this first one, we have 8/2 for the second one, then for the third one, we have 28/7. Now, if we simplify this, 8 divided by 2 is going to be 4. 8 divided by 2 is still 4. And if we do 28 divided by 7, we also get 4. So it's changing at the same rate. They just skipped some steps in here. So this would have a constant rate of change. So just because it doesn't change by the same interval every single time in the table doesn't mean that there's no constant rate of change. There still could be. There could just be values missing. And so it's important to go through all the steps, even if you don't think there's going to be a constant rate of change, because there may be one, it's just hidden. So for this one, we would say our constant rate of change is 4. All right, now let's... Oh, okay. Yep. So now let's look at proportional linear relationships. So this still deals with constant rate of change. So what this is it has a constant rate of change and it passes through 0, 0. So what that means is when we calculate our constant rate of change, so just like we've been doing, we'll go kind of quick through this one. So +2, +2, +2, and for our y's, we have +20, +20, +20. And then when we divide this out, we can see that it's $10 per hour, dollars per hour. So we have to figure out if this set of points goes through 0, 0. And how we're going to do that is we're going to want to walk it back to where we have 0 hours. Now, I know that might seem a little bit strange, but we want to figure out 0 hours. So in order to find 0 hours, we need to do 1 less hour than 1, which means we would do the proportional change on the right-hand side. So we would do $10 less on the right-hand side. So this is kind of a confusing concept, but the long story short of it is, if we were to make ourselves a separate table, so let's say I made a separate table up here, and it's going to be bare bones. We have our x's and our y's. They give us the values of 1 and 10, 3 and 30, 5 and 50. So they give us those values. Now I can go back and I can find any value of x in here. So they don't give us for 2 hours, but I know that if it's $10 per hour, then I know for 2 hours, that would be 1 hour more than 1. So I would add 10 and I would get to $20. Same thing with 3 to 4. I can say from 3 to 4, it goes up 1 hour, which means it goes up $10. So for 4 hours, it would be $40. And likewise, I can go backwards. So I could say, well, for 3 hours, it's $30. So to get to 2 hours, I would subtract 1 hour and I would subtract $10. So it'd be $20 for 2 hours. So what we want to do is we want to work back and see if at 0, our x value of 0, if we do have a y value of 0. So I would subtract 10, and I would find out in this case we do have a y value of 0 at x equals 0. So we would say there is a proportional linear relationship. So it can be a little challenging doing this in a table. Typically you'll see it in graphs, which is what we're going to look at next. So for this question, they say determine whether a proportional relationship exists between the two quantities shown in each graph. So what I'm going to do for this is I'm going to make a table so we can look at it in a table first. And then we're going to look at the graph. I'm not going to use the highlighter for that. So if I made just a quick table with my x's on the left, y's on the right, I'm going to put in 1, 2, 3, and my corresponding y values. So at x equals 1, my y value is 3. At 2, it's 6. At 3, it's 9. So in my table here, I can look at this rate of change and I can say, okay, we're going +1, +1, +3, +3. So there appears to be a constant rate of change here. So I'm going to check and see if the value of 0, 0 works. So to get to 0 on the x side, I need to subtract 1, which means I would have to follow the same pattern on the right side, so I would need to subtract 3, so I would get to 0, 0. And if we look at our graph, we can see that this graph goes through 0, 0, so there would be a proportional relationship. So the nice thing is when they give you a graph and ask if it's a proportional linear relationship, you can just look at this graph right away and you can say, okay, this line, it goes through 0, 0. So yes, there is a proportional linear relationship. Likewise, in a situation like this, we can see it doesn't go through 0, 0. So I know there's not a proportional linear relationship. However, I want to show you guys what it looks like in a table when you don't have a proportional linear relationship. So I'm going to look at this point appears to be right on, and I know this one's going to be right on. So I'm going to look at x values, y values. When x is 5, my y value is 70. When it's 10, my y value is 60. And I know when it's 15, now let's make it a little bit bigger here. 15, it'll be 50. So we'd follow the same steps. We'd say, okay, from 5 to 10, it's +5. From 10 to 15, it's +5. From 70 to 60, it's -10. And then from 60 to 50, it's -10 as well. So, is that correct? Yeah, that's correct. So now we would walk this backwards to find out what the value is at 0. So if I'm looking for an x value of 0, I need to go -5. And if I'm going -5 on this side, because that's the rate on this left-hand side, then I need to go -10 on this right-hand side as well. Or I need to go +10, because that's the opposite. So since we're subtracting 10 as we go down, we're going to add 10 to go up. So at x equals 0, I would have a y value of 80, which we can also see in the graph. So if my y value isn't 0 there, that means it is not a proportional linear relationship. I know that last part could be a little bit confusing. Make sure you write this down in your notes, and if you have questions, please let us